As we start solving equations, I know the beginning of this video is going to seem rather simple to you all, but I'm trying to emphasize certain points. First off, when we are solving an equation, we're trying to find the values of x which work in the equation. Sometimes we use the phrase satisfy the equation or make the equation become a true statement. One simple point: when we are solving an equation, we are not finding an answer, we are finding a solution. We tend to get a little bit lazy with our language. Now, the first question that people have is that of vocabulary and understanding the difference between an expression and an equation. Quite simply, if there is an equal sign, as we have in these first and third examples, then we have an equation. If, as in the case of this second line here, second problem, I don't want to call it an equation, there is no equal sign, then it is an expression instead. When it is an equation, we solve the equation. When it is an expression, we do not solve an expression, instead we simplify an expression. Now, in this next little section of problems here, determine whether the given number is a solution of the equation is a rather easy concept, and it's a rather important concept because this is how we check the solutions to equations. When we want to check whether 8 is a solution, that means substitute 8 in for the x. We get 3 times 8 is 24, and that would then be yes. 7 substituted into the next equation. 2 times 7 is 14, minus the 3 is not 17. 14 minus 3 would be 11. So no, 7 is not a solution to that equation. Let's try negative 3 in the third problem here. 2 times negative 3 is negative 6. Take 5 more away, you do get to negative 11. Thus, we would say that negative 3 works as a solution. We could say it satisfies the equation. We also say negative 3 is a solution to the equation. Now, when we move on here, solve and check each of the following equations, many of us can at the very beginning just say, oh, I see the answer. The answer here is 6. 6 plus 8 is equal to 14. And you're right. When the equations are easy, it's very easy to solve these by eye. But what we want to do is we want to develop a process that always works so that when the equations get a little more challenging, we know how to approach them. I'd like you to envision an equation as one of the old-fashioned scales, the types that you put weights on both sides. And the way you keep let me draw a picture of it here. The way you keep, let's pretend this is our little scale and here's our little measuring cups down on both sides. The way you keep this equation in balance is if you put a rock on one side, you have to put a rock of equal weight on the other side. In other words, what you do to one side of an equation, you must do to the other. In this case, we want to be able to say x is equal to 6, because 6 plus 8 is equal to 14. But technically, we've changed the left-hand side there. Technically, what we've done is we've subtracted 8 on the left-hand side, and so what we want to do to keep the balance of that equation is to subtract 8 on the right-hand side. Now the 8 minus 8 on the left cancels out, and the 14 minus 8 on the right gives us 6. And we've already mentioned that this checks when we substitute the 6 back in to the original equation. On this next problem, problem number 8, we want m equals. We see that 14 has been subtracted from m. We want to add 14 to both the left and right side of the equation. Whatever we do to the left, we must do to the right. And on the left, we're just left with m equals, because the 14s cancel each other out, and 22 plus 14 makes 36. Now let me caution you for a moment here. When I say whatever you do to the left side of the equation, you must do to the right side, that is a true statement. That did not give you permission to do whatever you want to both sides of an equation. Later on in this course, we will find certain things that you aren't allowed to do to each side of an equation. One of them is going to be dividing by variables. That's not allowed. Now, problem number 9 here. We're solving for the c. We see 13's been added to it. It doesn't matter that it's on the right side of the equation. That's fine. It's the c we're trying to isolate by itself. We want to undo the addition of 13 by subtracting 13 on each side. And on the left-hand side, we now have negative 19 equals the c on the right. And you can check that solution by substituting the negative 19 in for c, adding 13, and verifying that yes, indeed, you do get to negative 6 on the right-hand side. When your equations have fractions in them, you have a choice. You can either, in this case, just add 2/3 to both sides, which I will do because they have a common denominator. But typically when I have fractions in my equations, I clear the fractions at the start of the problem by multiplying through by a least common denominator. And you'll see that soon in another example. On the left, the 2/3 cancel, just leaving the w by itself. And on the right, we're going to have 13/3. And I'm going to leave that as an improper fraction. I'm not going to convert it into the mixed number 4 1/3 because we do not like mixed numbers in our algebra.